So we're going to do 7-4 today and tomorrow. I'm not going to give you homework today. But what I want to remind you is these are what your quiz was on last Friday, 2 Fridays ago. And we don't need to use them. We're done with them. What you're going to see today, we're going to do something called the double angle identity. And look at these new formulas. Never going to have you memorize them. Cool. They're going to be given to you. And it's just really applying. And you might say, well, what's the difference? Check this out. Before, the cosine formula was saying the cosine of some angle plus or minus a different angle. Now it's saying, oh, what's the cosine of two of the same angle? For example, if alpha equals beta, let's just go, which one do you want to do? Cosine or sine? I don't care. Sine. He says, I want to do the sine one. So he's saying, let's go down here. So you guys, all that they're saying, 2 thetas, is just like saying, what's an alpha plus an alpha? Meaning, I'm just going to have my 2 angles match each other. Because what's alpha plus alpha? What's 1 alpha plus 1 alpha? 2 alphas. So the sine of 2 alphas. I just wrote that as another.
Do you get it? Because I said alpha. It's giving alpha.
Cute. Okay. Here we go. Let's apply this if both my angles were alpha. Let's go apply this if both my angles were alpha. Alpha plus alpha. What would this turn into? What would this turn into? Sine alpha times cosine of alpha, right? And what about this part? Cosine alpha, sine alpha. Are these 2 things the same? Sine alpha, cosine alpha, sine alpha. They're the same. So what's 1 sine cosine plus 1 sine cosine? 2 sine alpha, cosine alpha. This right here is the double angle identity. Boom. So these right here are really just using these 3 formulas, just if my 2 angles were the same. Am I going to make us derive and figure all these out? No. But I just wanted to show you that they're what we've used before, just using 2 of the same angle. Here we go. Here we go. So now I'm going to say, all I'm going to give you is the sine of 1 angle, sine of theta, 1 theta, is 2/3. Now we got to go find out what the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta is. What? And that's going to be using these formulas. Check this out. You agree there's only 1 sine of 2 theta formula. You agree there's only 1 tangent of 2 theta formula. And then there are 3 cosines, like party time, 3 cosine of 2 theta formulas. Guys, it doesn't matter which of these 3 you use. Freya might think for one problem the first one's the easiest. Braddock might use the second one. Abby might use the third one. We'll all get the same answer. Makes no diff. Sound good? So let's go find the sine of 2 theta, which is going to be this orange formula. But first, we got to make a triangle with what they gave me. Cool. So you guys, it says the sine of 2 theta, is 2/3. And it says theta has its terminal side in the first quadrant. All that means is my triangle would be like this. And theta's here. So you guys, they told us the sine of theta is 2/3. So ka toa. Sine of theta is 2/3. So 3 is the hypotenuse. The opposite is beautiful. You gotta eat with that? Because we just did opposite over hypotenuse. Let's go find this leg. Let's go find this little leg. What would that be? Nice, you did that in 1 step. A squared plus b squared equals c squared. If you want to do it in multiple steps. 2 squared is 4. 3 squared is 9. 9 minus 4 is 5. You down with a being root 5? Perf. So now that we've got our triangle made up, let's go use this formula, which is the sine of 2 theta. All we got to do is say we got equals 2 times the sine of theta. You guys, didn't they give us the sine of theta? Sine of theta is just 2/3. What am I looking for again? I'm looking for the sine of 2 theta. That's why it's a little different. I got to multiply that by the cosine of theta. Using this triangle, what's the cosine of theta? So ka. Awesome. Adjacent over hypotenuse is root 5 over 3. Guys, why do you think I put my 2 like up? What's it really over? 2 over 1, I feel like helps us when we're multiplying because we multiply straight across, y'all, straight across. I don't want you to think that 2 goes to the bottom as well. What would we have up top? Over. Close. Perfect. Done. Now if I'm looking for the cosine of 2 theta, do you agree we got 3 different cosine of 2 thetas that we could use? Mario, which one do you feel like using? It makes no difference, bud.
I like the 2 cosines squared minus 1.
He's saying this one. He wants to use the middle one. I'm here for it. Boop, boop. Okay. People might disagree with it, and here's the deal. We don't care. If you disagree with it, go do the first one or the third one. I don't care. We're going to get the same answer. Cosine of 2 theta. You're saying we're going to say 2 times the cosine of theta. We got to square that, then minus 1. Mr. Bondi, the cosine of theta. I got to go find it, then square it. Here, we're going to use this again. Cosine of theta was how much? Adjacent over hypotenuse, which was root 5 over 3. You regret it? I don't blame you. But don't be scared. We got this. PEMDAS, what do we do first?
Parentheses.
Parentheses, and then the exponent. So we got to square this. What is root 5 over 3 squared? What's root 5 times root 5?
5.
What's 3 times 3? Perfect. So root 5 over 3 squared is just 5/9. We can do hard things, Mario. We got this. Then what are we going to do? Multiply or subtract? Yeah, PEMDAS, multiply and divide, go straight across. 2 times 5/9 would be 10/9. 10/9 minus 1. 10/9 minus 9/9. 1/9. Boom. So Mario regretted his decision. What's up?
I don't know what's happening. It's all right.
Mario regretted his decision, but Mario, we got it.
Yeah.
Ooh, which, say that again?
We weren't supposed to write that down.
No, you were. I was going to do it another way. Philip, were you seeing a different one that you rather wish that we did?
No, I got the same one.
You got the same one.
But the 2 times cosine squared minus 1 is what you said.
Oh, which way did you use?
2 times cosine squared
That's what we did.
minus
No. Ruh-roh. Just show you another way. What if we did the first one? What if we did just cosine squared minus sine squared? So Graham, tune in. If we were to do this one, let's just say that we use the top one instead. Cosine squared minus sine squared. Whoa, come back here, buddy. Cosine squared minus sine squared for the same problem. Boop. You don't have to write this down. But if I had cosine, so adjacent over hypotenuse, which would you agree is root 5 over 3? Square it. Minus the sine squared. Sine, so opposite over hypotenuse, 2/3 squared. What's root 5 squared? Root 5 times root 5? 5 over 3 squared? That's okay, good. 5/9 minus, what's 2 squared? 3 squared? 5/9 minus 4/9?
Oh my.
So we can get it the same, doesn't matter which one we use. Maybe I lost people on my 10/9 minus 9/9, but we're going to get the same answer.
Would that work in the calc?
No, I mean, yeah, but I don't want you using your calculator, especially if you want to go to Loyola.
Okay. You're really jazz. So it's a nice school. I like it. My favorite. And I like it. It's my favorite.
Tangent of 2 theta. We only have one formula to use, so we're going to use it. Tangent of 2 theta is 2 times the tangent of 1 theta. What's the tangent of theta here? Soka toa. Opposite over adjacent. Isn't it 2 over root 5? Yeah, opposite over adjacent. Oh, we can, but let's go ahead and leave it till we get to the final answer. Then we'll get rid of it. I dig that, dude. Over 1 minus the tangent of theta, the same value, then we got to square it. Toa.
1 minus
Uh-huh.
2 over root 5.
Yep.
Theta.
Square it.
Theta.
Nope, no theta. The tangent of theta is 2 over root 5.
Bad.
On top, what would we get when we multiply on top, right across? 4 over, careful, bud, just a root 5, good. We've got 1 minus, let's go square this guy. Say that again. 2 squared was 4. Root 5 squared, root 5 times root 5? 5. We're killing this, people. We're killing this. 1 minus 4/5. 5/5 minus 4/5. 1/5. 4 divided by root 5 divided by 1/5 is the same as 4 root 5 times 5. Multiply across.
20 root 5.
20 over, 20 root 5. I like it. And now Braddock pointed this out way ahead. He was like, guys, we cannot have a square root in the denominator. I agree. Let's go get rid of it now. Multiply by that root 5 on the top and the bottom.
20 root 5 over 5.
20 root 5 over 5, Philip says. And then, Philip, you're going to say 20/5 is just 4. Beautiful. Philip asked a good question. He's like, what's going on with this negative? Well, check this out, Philip. It's saying that my angle now is between 90 and 180 degrees. What quadrant is 90? Yeah, it's in that second quadrant. So let me show you. Guys, our triangle is going to be over here this time. Boom. Because that theta, they said, is between 90 and 180 degrees. My reference angle always goes to that nearest x-axis. And if they said the secant is negative 4/3, what's the reciprocal of secant? Which word? Cosine. So if I were you, I'd write underneath that the cosine is just going to be... Thanks, Sammy. Negative 3/4. Let's see why she got that. Secant and cosine are reciprocals. If secant is negative 4/3, boop, cosine is going to be the flip of it, negative 3/4. Let's go put that on our triangle now. Cosine, so CAH, C-A-H. Adjacent over hypotenuse. Doesn't make sense that this adjacent is negative because I had to go to the left. And then this y value would be positive to get up there. I want you to know, you guys, the hypotenuse is always positive no matter what. This 4, no matter if it was in the third, fourth, or first quadrant, will always be positive, that hypotenuse. If I had a point down here, if my theta was down there, then my x would be negative and my y would be negative. Am I going to test you on that? No. But I just want to throw it out there. You guys, they want to know the sine, cosine, and tangent of 2 thetas. Started with this. So let's go first find that y value using that Pythagorean theorem. What squared plus what squared equals what squared?
I'm going to go whopping a squared plus negative 3 squared.
Uh-huh.
3 squared equals 4 squared.
And I actually want you to do plus a negative 3 squared only because it has to be, we don't want minus in between there. A squared plus b squared equals c squared. My b just happens to be a negative. What is negative 3 squared?
Be a whopping 9.
So we got a squared equals 16 minus 9, which is 7. What's my a? Thanks, bud. A is root 7. Boom. All right, let's do it. Sine of 2 theta, we only have the choice of one formula. Margie, I know you weren't here at the beginning. I will give you all these formulas. We're just applying them, okay? Sine of 2 theta, let's go do it. It's just 2 times the sine of theta times the cosine of theta. So we've got 2 sine of theta, cosine of theta. Do I know what the sine of theta is? We can figure it out. So, SOH. Opposite. Hypotenuse. Root 7 over 4. Beautiful. Cosine of theta. They gave it to us, really, or we could look at our triangle. Either way, adjacent over hypotenuse. Ka, root negative 3 over 4. Guys, sometimes it helps us. Put that 2 over 1 just to make sure that we multiply correctly. Up top, what would we have up top? Beautiful. Over 16. Multiplying straight across. Does this simplify at all? Negative root 7 over. Beautiful.
10.
Well, we got to do cosine. We got 3 cosine ones to pick from. They
choose-
gave us this.
I'm going to think number 2.
The second one?
Yeah.
Because the sine is the one that's got the root 7 in it. So maybe we avoid the sine stuff.
I agree.
Okay, so he says, let's go with the second one. Boom, I'm fine with that. That is 2 cosine of theta. We wrote that right here. The cosine of theta was how much? Negative 3/4, love it. Square that. Then what do we have to do to that? Minus 1. Ooh, do I multiply 2 in first? No. PEMDAS says parentheses, then exponents. So I leave my 2. Negative 3, square it. 9, 4, square it. Minus 1. Do I do 9/16 minus 1? 2 times 9/16, because we got to do PEMDAS, which is multiply and divide before add and subtract. 2 times 9/16 would get me 18/16. Minus 1. 18/16 minus 16/16 is 2/16, or just 1/8. I want us to be able to say, oh, I need common denominators, but 1 is the same as 16/16. Question, could I have done this earlier? Could I have said 2/16 is 1/8? So then I'd have 9/8 minus 1. 9/8 minus 8/8 would be 1/8. So you could simplify at any point. It's just like you saying that you want to get rid of the square root earlier. Either way. So I'm going to give you guys the time. I want you to try to set up the tangent of 2 theta. Here's the formula for you. Bloop. Go try to set that guy up from my triangle. Okay. What is it? 2 tangent TOA root 7 over negative 3. All right. 1 minus root 7 over negative 3. We got to square that. Here we go, peeps. What do we got on top?
We're going to get a 2 over 1, and it's going to be 2 root 7 over.
Beautiful. 1 minus root 7 times root 7? 7. Negative 3 squared. Yes. Yeah, let me show you, Margie. Here's my theta. So TOA, since we need the tangent of theta, TOA is opposite over adjacent. Yep. Perfect. You guys, what are we going to do on that bottom? 1 minus 7/9 is the same as 9/9 minus 7/9. 2/9. 2 root 7 over negative 3 divided by 2/9. 2 root 7 over negative 3 times 9/2. Agreed. You could cancel some things out now, or you could just multiply across and cancel later. Whatever floats your boat. What do you feel like doing? He says buy 2s. I'm good with that. Oh, I like that. You saw the 3s too. 9 divided by negative 3 would leave me with what? A 1 here and a negative 3 up there. Awesome, Dowdy. What would that leave me with? Negative 3 root 7 over 1, but we don't need the over 1. So don't you fret, Mr. Beck. Check this out. If you did not cancel anything out, don't worry about it. Let's multiply across. Up top, wouldn't I get 18 root 7 over? Yeah. So Beck, you really don't need to simplify early because check this out. What's 18 divided by negative 6? Negative 3. And we get the same answer, so don't fret.